So there's multiple ways to draw the dot structures. Here, I'm going to teach you a different way than what you guys learned in the previous lecture. So this is going to be a different way of drawing covalent compounds. So first thing you can do is you can count how many total valence electrons there are. So count all the valence electrons. Okay, so what do I mean by that? This molecule, N2H2, is made out of N, N, H, H, right? There's 4 different elements. There's 2 N's, there's 2 H's. So what you can do is you can first count how many valence electrons there's going to be total. So before you even start planning what the molecule is going to look like, let's write down how many valence electrons every single atom is going to bring. So let's look at N. How many valence electrons is N going to bring? So N is number 1, 2, 3, 4, 5. It's box number 5. So N is going to bring 5 valence electrons. Okay, but there's 2 of them, so we just multiply that by 2. So the N's are going to bring 10 valence electrons. Hydrogen has 1 valence electron because it's the first box. So 1 valence electron, but there's 2 different hydrogens. So we're going to have to multiply that by 2. So if we multiply that by 2, that's going to be 2 total valence electrons. So here, the N's, each of them brings 5, and there's 2 of them, so 10. And the H's bring 1 each, times 2, which is 2. So that means this molecule in total is going to have 12 valence electrons that you have to work with. Okay, so what we're going to do is we're going to follow these rules to kind of set up what our molecule looks like. So N2H2. So we know that H goes on the outside. So let's put H's kind of on the outside. And that means we'll put the N's on the inside. All right, so, and this will be our how the electrons are shared. So I'm going to put part A. Okay, so the reason why we counted the valence electrons is because this tells us how many electrons we can draw and how many lines we can draw. So we know already that every single atom needs to be connected. Okay, so what we're going to do is we're just going to create lines so that every single atom is connected. Okay, we know that 1 line is going to be equal to 2 electrons. So every time we draw a line to connect the elements, the atoms, we're using 2 electrons. So if I just connect everything together, how many electrons did I use? I used 2, 4, 6. I used 6 electrons. That means that I have 6 valence electrons left to work with. Now we said the octet rule, everything needs 8. Every single element needs 8 valence electrons except for hydrogen, because hydrogen needs 2. Now, we're already done with hydrogen. Hydrogens are good to go, because if you notice, hydrogen has a line connected to it. That means it's using 2 electrons. So hydrogen is happy, and this hydrogen is happy. The only thing that we have left to do is make sure that these nitrogens are happy. Okay, so let's kind of I'm going to write down some things just so that we keep these in mind. So these hydrogens are happy because they have 2 valence electrons, right? Because they have a line. And this hydrogen is happy because it has 2 valence electrons. But let's count how many electrons these nitrogens have. This nitrogen right here has 2 lines connected to it, so that means it has 4 valence electrons. And this one also has 4 because there's 2 lines, right? 2, 4. So that means we need to use these 6 electrons so that both of these nitrogens can get to 8. So we kind of have to play a game to figure out how to get it to 8. So let's say I just try to get this nitrogen to 8. I used 1, 2, 3, 4. That makes this nitrogen 8. Okay, so this nitrogen is happy now. This hydrogen is happy. This hydrogen is happy. Okay, but this nitrogen is not happy because it only has 4. But we just added 4, so that means we have 2 left. So I'm going to put 2 electrons here. and now we have 0 left. Okay, and this nitrogen has 6. Okay, the problem though is that this nitrogen needs 8, right? Remember the octet rule. This nitrogen needs 8 valence electrons. So what we're going to have to do is we're going to have to make it so that both of these nitrogens can have 8. Now, we can't just take 2 electrons and put them here, because then this nitrogen is going to be unhappy. So instead, what we're going to do is we're going to make these nitrogens share 2 of the electrons. So we're going to take the 2 that were here, and then we're going to put another line in between. If we put another line in between, both of these nitrogens have 8, because this nitrogen has 2, 4, 6, 8. This nitrogen has 2, 4, 6, 8. And there we go. Our structure is good to go. We have 8 electrons for both nitrogens, and we have 2 for both hydrogens. And if we wanted, we can only use 12 total. We have 2, 4, 6, 8, 10, 12 valence electrons. So this is how the electrons are going to be shared. All right. For part B, let's draw the stick structure. Stick structure is very simple. We just don't draw these dots. So we can do N, H, dash N. And then we want 2 dashes, and we want an H. And so this is going to be our stick structure. For how many bonds we have, what types of bonds, every line that's by itself is a single bond. So we have 1, 2 single bonds. And then 2 lines are going to be a double bond. So we have 1 double bond. All right, and there you go. That's going to be your answer for number 1. So if you feel pretty confident trying these out on your own, you can pause the video and try number 2. But if not, I'm going to take it step by step. All right, so for number 2, we're going to use this method where we count the valence electrons again. So if we look at C on the periodic table, first we're going to figure out how many valence electrons C provides. Okay, C is box number 1, 2, 3, 4. That means C is going to provide 4 valence electrons. Hydrogen is box number 1, so every single hydrogen provides 1. So we have 1, but there's 3 of them, so that's going to be times 3, which will be 3. Oxygen, if you count the boxes, is going to be box number 5, 6, so oxygen is going to provide 6. Hydrogen outside is going to provide 1. So here we have 4, 3, 6, 1. So how many total electrons do we have to work with? We have 14 valence electrons. So when we're drawing the structure, what we can do is we can start organizing these atoms together using these rules. So we said earlier that the C has to go in the middle and H goes on the outside. So I'm going to put C in the middle and I'm going to put the H's around it. Now if you notice with this formula, the H's are separated, right? There's CH3 and then there's another H, OH. Okay, remember from the last lecture that if they're separated like this, it kind of tells you which one it's connected to. So these 3 H's are probably connected to the C because it's right next to the C. And this H is probably connected to the O because it's separated from the other H's. So we have 3 H's around the C because C goes in the middle, H goes on the outside. And then we're going to write O, and then H is probably connected to the O. So I'll put the H right there. All right, now what we're going to do is we are going to draw lines in between all of the atoms. So we said that the H's are going to be connected to the C, and this H is probably connected to the O. And in order for it to be a molecule, all of the atoms need to be connected together. So we're going to connect the C and the O. We said that we have 14 valence electrons to work with. What that means is we need to make sure we count how many lines there are. Every line is 2 electrons, so one line is 2 electrons. And so let's count how many electrons we use. We have 1, 2, 3, 4, 5 lines. If we have 5 lines, that means we used 10 electrons. and we only can have 14, so that means we have 4 electrons left. Okay, we can only use 4 more. Okay, let's figure out which atom needs electrons. So if you remember, H needs 2 valence electrons. If H needs 2 valence electrons, what that means is every single H can only hold 2. It could either have 2 dots around it, or it can have 1 line coming out. Now if you look at all the H's, all the H's are happy because the H's all have 1 line connected to it. Okay, so for carbon and oxygen, we need to make sure we follow the octet rule. That means they both need to have 8 valence electrons. So carbon, if you count how many electrons it has 2, 4, 6, 8. So this one is using 8 valence electrons already. So this carbon is happy. But oxygen has only 2, 4. It only has 2 lines connected to it. That means this oxygen is only using 6 valence electrons. But we have 4 left. Oh, I'm so sorry. It's using 4 electrons, 4 valence electrons, because there's 2 lines. Sorry about that. Disregard what I just said. Oxygen has 4 valence electrons because there's only 2 lines connected to it. So oxygen still needs 4, but carbon has 8. That means only oxygen needs more electrons. Lucky for us, we have 4 electrons left to use. So what we're going to do is we're just going to draw 4 dots on oxygen, which means oxygen is now at 8, and we've used 14 valence electrons. You can also check your answer by counting the lines and the dots. We have 2, 4, 6, 8, 9, 10, 11, 12, 14. So there you go, guys. That's going to be how the electrons are shared for your for this molecule, CH3OH. Okay, for our stick structure, all we need to do is basically copy it down without any of the dots. Okay, and then lastly, we just count how many of each bond we have. So if you take a look at it, this molecule only has single lines, so it only has single bonds. It has 1, 2, 3, 4, 5 single bonds. So this one has 5 single bonds.